PU2 aspirants, so I hope all of you are working really hard, studying day and night for your chemistry PU2 examination. So we have already done the revision of organic chemistry, name reactions, top 50 questions, and I hope that all of you have watched it and revised all the questions, okay? And while doing this video, I saw so many comments with MCQs and numericals. Ma'am, MCQs, ma'am, numericals, MCQs, numericals. So I thought to change my plan a bit, and I will be first giving you the MCQ videos today. So we are going to discuss top 100 MCQs of all the 10 chapters, and the best thing is these MCQs have been taken from your PU question bank, okay? The PU question bank that is released by the government, from there I have taken these 100 MCQs, the most important ones. So let's get started with the first question. So first one will be from the solutions chapter. The question here is the relationship between the osmotic pressure at 273 Kelvin when 10 gram of glucose, 10 gram of urea and 10 gram of sucrose are dissolved in 250 ml of water. See, this is very tricky question, but yes, not that difficult. We have osmotic pressure pi is equal to C into RT, right? C is what here? Molarity. How can I write here? Given mass by molar mass into 1000, right, by volume R into T. Ma'am, do we have to do these many calculations in MCQ? No, my child. See, what you have to do, you can see that pi is inversely proportional to molar mass, right? So we have the first one here is glucose. So I can say that for glucose, or I can say P1 will be proportional to glucose mass is 180. All of you should be remembering the glucose mass by now, okay? Then urea is 60. These all are, this is fixed, right? This 10 gram is also fixed for everything. Pi P2 is what? Proportional to 1 by urea mass is 60. Then we have sucrose. Sucrose mass is P3 1 by 342. Okay. Now what is happening? You see, if the mass is less, inversely proportional, mass is less, then pi will be higher value, osmotic pressure will be higher. So what I can say here is P2 will have the highest value. So I can see two options with P2 highest value. I will eliminate the other two. Next, which one will be the lowest? The lowest where the molecular mass is highest, right? So that is 342. So P3 will be the lowest value. So the correct answer for this question is option number A, and I hope all of you are clear with this. Moving to question number 2. Blood cells retain their normal shape in a solution which are, so hypotonic, isotonic, hypertonic or equinormal to blood. So if it is hypotonic, then blood will flow inside it, the cell will swell. If it is hypertonic, water will go out from the cell will shrink. But if it is isotonic, then the solution or the blood cell will remain in its natural condition, okay? Next, out of the following 0.1 m aqueous solution, which one will exhibit the largest freezing point? Okay, this is very tricky question, and I know many of you will do wrong here. Please understand this question properly. Largest freezing point, okay, will have the largest freezing point depression. Okay, there is two different thing here. If the question is which one will have largest freezing point, and largest freezing point depression, okay, the two different things are there. I will explain both of them, so be very careful here. So first of all, we know that delta TF is equal to I into KF into M. I value we have to find out, in which case I value is higher. This is 2 here because K plus and Cl minus. This is a non-electrolyte, so here I value is 1. Here we will have 2 plus 3, 5. Here we have 3. Right? So if I value will be more, delta TF will also be more. So in this case, for freezing point depression, largest delta TF will be highest where I value will be equal to 5 here. So correct answer is option number C. But if the question would have been which one is having the largest freezing point, okay, this is very important, very important, please listen carefully. Largest freezing point, okay. So now what happens, there will be depressions, okay. Now you see, if I say this is suppose the initial freezing point, just imagine you have I equal to 2 value, so it will decrease to, suppose I will take here up to here. Here I value is 1, so this will decrease up to here. I value is 5, it will decrease here. I value is 3, it will decrease here. So now you see this is option A, B, C, D. These are the freezing points. These are the freezing points that has decreased. So which one is having the highest freezing point? The lowest one is obviously this one, but the highest one is this one, right? So the one which is having the largest freezing point is where the depression is minimum. That is your option number B. Be very careful, tricky question. Please do not do this wrong. I have seen many students doing this wrong question. Okay. Next, we'll move to question number 4 here. An aqueous solution is 1 molar in Ki. Which change will cause the vapor pressure of the solution to increase? Okay, so we have vapor pressure of the solution should increase, right? So vapor pressure is due to what? Vapor pressure is due to the solvent, right? So if we increase the solvent, vapor pressure will increase. If I add these solutes, what will happen? Vapor pressure will decrease only. So addition of water, that is the solvent which can evaporate, which can create the vapor pressure, will increase the vapor pressure. So that is why option number D here. Next, we have 5th question. Which of the following salt has the same value of Van 't Hoff factor as that of K3FeCN6? Okay, so if you see a Van 't Hoff factor, how will this dissociate? This will give you 3K plus and FeCN6 3 minus. Okay, so how many we will get? 3 plus 1, 4 ions I will get. Okay, 4 ions will be produced. Now here if you see 2 plus 1, 3, here 3 plus 1, 4, here 3 plus 2, 5, and here it is 2, right? So which value is matching? It is aluminium nitrate, that is option number B here. Okay. Next, we have question number 6. At 25 degrees Celsius, the highest osmotic pressure is exhibited by 0.1 m solution of highest osmotic pressure. So if you see pi is equal to I into C into R into T, C is already given 0.1, R is constant, T is constant, so it will directly depend on I value. So here I value glucose is 1, urea is 1, KCl is 2, calcium chloride is 3, right? I value 3, more osmotic pressure, so option number C here. Next, we'll move to question number 7. Which of the following aqueous solutions has the minimum freezing point? Very, very, very important question. Minimum freezing point. Again, so see, you have to see the minimum, means lowest freezing point. Okay, so we can see here that here I value is 2. Okay, here the I value is 1. Okay, and here I can say that I value is 3, yes, here the I value is 2. Okay, next I will also count here delta TB, delta TF is equal to I into KF into M, right? Which of the following aqueous solution? So the solvent is water in all the case, so KF value is also constant here. I into M I have to do. For option number A, how much I will get? I into M, 0.01 into 2, that is 0.02. For this one I will get how much? 0.005 into 1, that is 0.005. Next, C here where it is 0.005 into 3, so it will be 0.015. Okay, so I will get this one. Next, D option, we have here 0.01. Okay, 0.02, 0.005, 0.015 and 0.01. Now what we can see where the freezing point is minimum. Okay, so see, you have like this graph, suppose freezing point is decreasing, right? The freezing point depression will depend on this delta TF value, and it is maximum here 0.02, I think here it is 0.01, 0.1. So yes, option number A has to be the correct answer, that is option number A. Okay, which of the following equations has the minimum freezing point? So you have to check both I and M, because M is not constant here, right? So I will multiply I and M, I will multiply I and M, and I'm getting that here although 3 is there, right, but I'm getting the value here is 0.015, right, which is less than this one. So definitely here the freezing point will be minimum, depression will be minimum. Okay, next question number 8. For 0.1 m solution, the colligative property will follow the order. Okay, so colligative property will depend on I value. So we can see that the I value here is 4. So I have 3 options: NaCl, Na2SO4 and Na3PO4. Okay, so this is 2, this is 3 and this is also 4. So I have here Na3PO4, Na2SO4 and NaCl. So that is option number B here. Okay, next we have question number 9. Statement 1. If the red blood cells were removed from the body and placed in pure water, pressure inside the cell increases. Okay, the concentration of the salt content in the cells increases. Okay, so you have taken pure water. Okay, here your blood cell is there and here pure water is there. So what will happen? Water will flow inside the cell, right? Water will flow inside the cell and that is why the pressure will increase. The concentration of the salt content in the cell increases. No. See, suppose some salt was there. What is concentration formula? Now, number of moles by volume. Now when more water is increasing, volume is increasing, concentration will decrease. So statement 1 is correct but statement 2 is false, right? So that is your option number C. Statement 1 is correct but statement 2 is incorrect here. Okay, now moving to question number 10. During the depression of freezing point in a solution, the following are in equilibrium. This is very, very important. When the freezing point depression happens, exactly what is the, if you have seen the graph here, this is like this. Okay, so here it is the vapor pressure of the solvent, solid solvent. Okay, and this one has to be the vapor pressure of the liquid solution. Okay, so liquid solvent and solid solvent, liquid solvent and solid solute. So there is no interaction of the solute. Okay, so we can eliminate these two options. Solute is not there at all. Liquid solute and again solute is not there, so we can eliminate liquid solvent and solid solvent. Vapor pressure of the solid solvent and vapor pressure of the liquid solvent should be at equilibrium, so option number A here. Okay, now we will move to the next chapter, that is your electrochemistry. See the first question: which of the following statements associated with electrochemical cells is incorrect? The function of a salt bridge in an electrochemical cell is to complete the circuit. Cell potential is the potential difference in a voltaic cell. A Bronsted-Lowry acid-base reaction can be used as the basis of the net reaction in a chemical cell. A half reaction corresponds to 1 electrode in a voltaic cell. So which of the following is incorrect? So we have studied that the basic of electrochemistry chapter is your redox reaction, right? So how can an acid-base reaction help in this electrochemistry? No, right? So the incorrect statement is option number C. A redox reaction can be used as a base for this electrochemical cells, but not an acid-base reaction. Next question, these questions are very, very important. Okay, the standard electrode potentials are given. The correct order, decreasing order of reducing power here is, okay. Here many students mug up many things, but I want you to be understanding the concept. Very, very simple thing. See, when I am talking about, we have been given with the reduction potential, right? Let me first note down that values. So I have aluminium plus 3 to aluminium. Then I have silver plus 2 silver. Okay. Then I have K plus 2 K. Okay. Next I have Cr3 plus 2 Cr. Okay. These are the values we have given, and I have minus 1.66 volt, and then plus 0.8 volt, minus 2.93 volt, and we have minus 0.74 volt. Now what is this reduction potential? The tendency to get reduced, right? So what I can say here is Ag plus reduction potential is positive, means Ag plus wants to get reduced easily, or the tendency of Ag plus to get reduced is very high. So when it is reducing others, or when it is reducing itself, it is undergoing reduction, it will behave as an oxidizing agent. Okay, when the species is undergoing reduction, it will behave as an oxidizing agent. So if I just write down tendency to get reduced is equal to, itself it is undergoing reduction or it will oxidize others, so it is behaving as an oxidizing agent, is equal to the oxidizing potential or oxidizing power. Okay, so what is the order for this one? You have Ag plus, then you have after 0.8 what I will get, minus 0.34, that is Cr3 plus, then I have Al3 plus, and then I have K plus. So now what happens, see, here tendency to get reduced, so Ag plus is having more tendency to get reduced, so it will be the best oxidizing power, right? Here K plus is having the least tendency to get reduced, that means it has the highest tendency to get oxidized. If it is oxidizing better, then it is a very good reducing agent. Okay, so K plus can oxidize better and a very good reducing agent, so that is why we have reducing power, so K will be at the top. Okay, we can eliminate this too, and Ag plus will be at the end. We have only one option like this, so option number C. I hope you are getting. This is the reducing power order, so automatically, so this is the oxidizing power order. Then what will be the reducing power order? The one which is highest will be the lowest here, right? K, Al, Cr, Ag. Done. Next we have here question number 13. A button cell used in the watches function as the following. Okay, half cell reaction, E0 values are given. The cell potential will be, okay, so you can see here that Zn is undergoing oxidation, silver is undergoing reduction. So Zn undergoing oxidation means zinc is anode, okay, and silver is undergoing, so this is cathode, okay, anode and cathode. So E0 of cathode minus E0 of anode, right? So I will get 0.34 minus 0.76. So what I will get, 6 plus 4 10, 7 plus 3 10 11, so that is 1.1 volt. Do I have that in option? Yes, option number C here. Okay, next moving to question number 14. The standard reduction potentials are given, the strongest oxidizing and reducing agents. Very, very important question, just now we discussed. See, reduction potentials are given, tendency to get reduced is given, that means tendency of oxidizing power is also given. So if I see which is having the highest tendency to get reduced, this one, it has the highest tendency to get reduced, so it will be the one which will have the highest oxidizing power. So oxidizing agent, the strongest oxidizing agent will be fluorine, that is here. Okay, and I have only one option with that, so I minus. So if it is, I am next one, if I want to find the reducing agent, itself it reduce others, itself it will get oxidized. Oxidize it will be undergoing, means its reduction potential should be very low. So which one is having the least reduction potential? This one, right? So your very good oxidizing agent will be I minus, option number A here. Next, question number 15. Standard electrode potential of Sn is given and that of chromium is given. These two couples in the standard state and are connected to make a cell. The cell potential will be, okay, so here you should be knowing which one will be cathode and which one will be anode. The one whose reduction potential is greater will be a cathode, the other one will be an anode. So here Sn reduction potential is higher and chromium reduction potential is less, right? So cathode minus anode it will be there, so I can have 0.15 minus 0.74. Okay, so what I will get, 5 plus 4 9, 7 plus 1 8, 0.89 volt, that is option number C here. Okay, okay, next moving to question number 16. Consider the following relations for the EMF of an electrochemical cell. This is also a very important question. See, you should be knowing that E0 of a cell, okay, is equal to E0 of oxidation plus E naught of reduction. Okay, clear? E naught of oxidation plus E naught of reduction. Or I can write E naught of anode is one which undergoes oxidation plus E naught of cathode which undergoes reduction. Now if I want to represent both of them, okay, I want to represent both of them in one form, either in the form of reduction or in the form of oxidation. So now if I want to represent in the form of reduction, so cathode undergoes reduction, so that will remain like this, but anode actually undergoes oxidation. We want to represent it in the form of reduction, so this one will become minus. So what I will become? E naught of cathode reduction potential minus E naught of anode reduction potential. Now similarly, if I have oxidation potentials, okay, yes, if I want to mention oxidation potential, so cathode, anode will remain as it is, but cathode where it is actually undergoing reduction, you want to write its oxidation potential, so what will happen? This one will become negative. So E naught of anode oxidation minus E naught of cathode oxidation. Okay, so these are the ways how you can represent the cell. So first of all, let's see, EMF of the cell is equal to oxidation potential of anode minus reduction potential of cathode. Okay, here this one is wrong. We have seen the first equation is oxidation potential of anode plus reduction potential of cathode. This one is of anode and this one is of cathode. So you have to find the correct relation, right? So one is not there, so I will eliminate which options I can eliminate, these two. Okay, next I have to check between 2 and 3 because 4 is common in both of them. Okay, EMF of the cell is equal to oxidation potential of anode plus reduction potential of cathode. Yes, this is the first one, so definitely 2 is correct. Okay, so it has to be the correct answer, option number D. By elimination method I am telling, but let us check the other option. EMF of the cell is equal to reduction potential of anode, okay, plus reduction potential of cathode. No, anode undergoes oxidation. If you are writing its reduction potential, it has to be negative, so that is why this is incorrect. Next, oxidation potential of anode minus oxidation potential of cathode. Yes, cathode actually undergoes reduction, but if I want to write its oxidation potential, it has to be negative, so it is 2 and 4. Okay, good question this one. Next we have, based on the following E naught values, the strongest oxidizing agent is. Again the same thing, the reduction potential values are given, it will reduce itself, that means it will oxidize others. So the one which is having the highest reduction value is, I think, 0.35, right? Minus 0.35, then 0.77, right? Out of this one, which is undergoing reduction, if you see FeCN6 4 minus is undergoing reduction to this one, so that means FeCN6, I can see here, this is plus 2 and here it is one second, x minus 6, this is plus 2 and here it is FeCN6, okay, this is plus 3, sorry, this is oxidation potential is given then. We are very careful. See, plus 2 to plus 3, that means this is your oxidation potential is given. Oh, just a minute. Yes, this is oxidation potential given. For here also oxidation potential is given. Okay, very tricky question. See, you want to find oxidizing agent, right? It will oxidize itself. It will oxidize others. Oxidizing potential or oxidizing agent is something which can oxidize others, itself it will get reduced, right? So for reduction, the reduction potential should be high. Reduction potential should be high means oxidation potential should be low. Why? Because the answer is, the question is oxidation potential. Let me repeat it. It is behaving as the strongest oxidizing agent. It will oxidize others, itself it will undergo reduction. For undergoing reduction, the reduction potential should be high. That means the oxidation potential should be low. So if I check this one, this is the one where oxidation potential is lower, right? So now you can see that Fe2 plus to Fe3 plus is behaving as a what? Fe2 plus will behave as a reducing agent and Fe3 plus will behave as an oxidizing agent. The correct answer here will be option number A. See, Fe2 plus is undergoing oxidation, so it will behave as a reducing agent. Fe3 plus will undergo what? Reduction, so it will behave as an oxidizing agent, so that is why option number A here. Next, which of the following statements is true about a galvanic cell? Cathode carries a positive charge. Yes, that is correct. Anions migrate through towards the cathode. Okay, let's see. The electrons are released through the anode. Yes, this is also correct. Reduction occurs at anode. No, reduction does not occur. It is always the oxidation where the anode occurs. So we have this option. And here their ions do not migrate, or anions do not migrate, rather electrons migrate, right? So 2 and 4 are incorrect. So correct answer is option number D here. Next we have question number 19. A solution of potassium bromide is treated with each of the following. Which one would liberate the bromine? Okay, fine. So you have a solution of KBr, okay, and you are reacting them with each of the following. Okay, so if I have, so for example, I am reacting with chlorine, so what I will get? KCl and Br2 I will get. Okay, similarly if I am reacting it with iodine, okay, then I will get Ki plus I2, okay, Ki plus Br2, sorry. So which of this reaction will be feasible? So what is exactly happening here? If you see, chlorine is undergoing reduction and iodine is undergoing reduction. Reduction means gain of electrons. So out of chlorine and iodine, which is the one which can gain electrons better? Chlorine definitely, because it is having higher electronegativity. So chlorine will gain electrons and it can reduce this one, or it can undergo reduction, and the bromine can undergo oxidation. So the correct answer here has to be option number C, that is chlorine. Next, let us see question number 20. Now let us go to the next chapter, that is your chemical kinetics. Okay, so the question here is, for a first order reaction, the plot of log R0 versus R versus time will be. So it is always a straight line. Okay, so straight line with all it is there, with a negative slope and positive intercept. No, it is a positive slope. Okay, so if you remember, the graph is like this. KT by, I can write 2.303 is equal to log of R0 by R. Okay, and here the slope is K by 2.303 and the intercept is 0, right? So 0 intercept and I have positive 0, so I can eliminate these two. Okay, next here we have positive slope and here it is also 0 slope. No, slope is not 0 here because slope value is K by 2.303, positive slope. So the correct answer is option number C here. Next we have question number 22. The thermal decomposition of HI in the presence of gold is an example of a reaction of 0th order reaction. Remember, all the surface chemistry reactions, or though where catalyst is involved, these are generally 0th order reaction. Decomposition of N2O5 and N2 are some of the examples for first order reaction. So here these are direct theory based question. So please remember, N2O5 decomposition is a first order reaction. Half life of a 0th order reaction is inversely proportional to. So if you have this formula, T half is equal to A0 by 2K, right? So it is inversely proportional to the rate constant. So that is why option number C. Next, select the incorrect statement with respect to the pre-exponential factor. So where do we use pre-exponential factor? In the Arrhenius equation, right? What is this pre-exponential factor? It is also called frequency factor. It is the constant for a particular reaction. Its value is specific for a particular reaction. Okay, just a minute. It is represented by EA in the Arrhenius equation. No, EA stands for activation energy. It is represented by A. So the incorrect statement is option number D. And B and C are almost a very similar statement. Next, kinetic energy possessed by the maximum fraction of molecules is called as, okay, average kinetic energy, most probable kinetic energy, maximum kinetic energy, root mean square kinetic energy. So if you see the Boltzmann curve, okay, it is like this. Okay, you see here the fraction of molecules and this side it is energy. So the fraction of molecules which possess the maximum number of energy, that is your most probable kinetic energy, option number B. Means this is this fraction, the highest fraction or the highest value possess this energy. Okay, it is not the maximum energy. See, this particle energy value is here, right? So this is the one which is having high energy, this is the one which is having low energy, but here the fraction of molecules are less number of molecules have low energy and high energy. Maximum number of molecules have one I can say average value of energy, which is called as your most probable kinetic energy. Next, here the area under the Maxwell-Boltzmann distribution curve is the fraction of molecules reacting at time t and is constant, total energy of the reaction, activation energy of the reaction, enthalpy of the reaction. It is the fraction of molecules reacting at time t and it is a constant value. Okay, the graph of the thing always remains constant. Next, in the Arrhenius equation, the factor e to the power of Ea minus Rt corresponds to the fraction of molecules having energy greater than or equal to activation energy, right? Fraction of molecules that have energy equal to or greater than Ea, fraction of molecules that have kinetic energy less than A. So these are all wrong. Yes, this is the correct answer. Next, we have catalyst alters the Gibbs free energy. No, catalyst does not affect the equilibrium constant as well as the Gibbs free energy. So statement 1 is false, and the next statement, catalyst catalyze the forward reaction as well as the backward reaction to the same extent. Yes, this is correct. So statement 1 is correct and 2 is incorrect. So that is option number C here. Next, when initial concentration of a reactant is doubled in a reaction, its half-life is not affected. The order of the reaction is. This is very simple. We know that for a first order reaction, the T half value is 0.693 by K. Okay. So what will be the value here? That is your first order reaction, option number A here. Next, we have question number 31. We'll move to D and F block chapter. Yes, this is again important question here. KMnO4 acts as an oxidizing agent in acidic medium. The number of moles of KMnO4 that will be needed to react with 1 mole of sulfide ions in acidic solution is. Okay, fine. So let us see here. If you see in acidic medium, what happens? MnO4 minus, okay, gets S2 minus, gets converted to Mn plus 2, and this is S. So this is plus 7, okay, plus 7 to plus 2 we have 5 electrons, and minus 2 to 0 we have 2 electrons. Now this one to balance I will multiply with 2, so I will write 2 MnO4 minus and 2 Mn2 plus, and this one to this I will multiply with 5 S2 minus and 5S. So now what we can do is, okay, the number of moles of KMnO4 that will be needed. So according to this equation, I can say that 5S2 minus requires 2 moles of MnO4 minus, right? Then 1S2 minus will require 2 by 5 moles of MnO4 minus, right? So the correct answer here will be option number A, 2 by 5. Next, we have question number 32. Which of the following oxides is amphoteric in nature? So here we have V2O5 and Cr2O3, option number A. So direct theoretical based question, so you should remember the examples. Next, interstitial compounds are formed when the small atoms are trapped inside the crystals of the metals. Which of the following is not the characteristic property of the interstitial compounds? They have high melting points. Yes, they are very hard. They retain the metallic conductivity. That is also correct. They are chemically very reactive. No, they are chemically inert. Okay, so the incorrect statement is option number D here. You have to find not the characteristics. Next, we have the magnetic moment is associated with its spin angular momentum and orbital angular momentum. The spin only magnetic moment of Cr3 plus is. So we have chromium here. Okay, so chromium is 3d5 and 4s1, and chromium 3 plus, okay, it will be giving me 3d3, I think. So 3d3 means we have root over of 3 into 3 plus 2. So if you remember, if 3 unpaired electrons, so it is 3.87. So correct answer is option number B here. Okay. Next, question number 35. KMnO4 acts as an oxidizing agent in an alkaline medium. When alkaline KMnO4 is treated with Ki, iodide ion is oxidized to. So this is very important. You should remember, I minus is converted to I2 in acidic medium. Okay. And I minus is converted to IO3 minus in neutral medium. Okay. So where it is? That is option number C. Next we have here question number 36. Which of the following statement is not correct? Copper liberates hydrogen from acids. You have to find not correct. Okay. So copper does not liberate hydrogen from the acid, right? Because copper reduction potential is very high. Copper itself gets reduced and does not allow hydrogen to get reduced to release the hydrogen gas. So that is why here incorrect statement is option number A. We don't have to read the other options. When acidified K2Cr2O7 solution is added to SN2+, then SN2+ changes to. So it is an oxidizing agent. SN2+ will be oxidized to SN+4. Okay. Next, question number 38. Highest oxidation state of manganese fluoride is +4, but highest oxidation state of oxides is +7. Because, so yes, fluorine is more electronegative. Fluorine does not possess d orbitals. Fluorine stabilizes the lower oxidation state. In covalent compounds, fluorine can form single bonds, whereas oxygen can form double bonds. That is why higher oxidation states are stabilized by both fluorine and oxygen, but better stabilized by oxygen because of its ability to form double bond. Next, although zirconium belongs to 4D transition series and hafnium belongs to 5D transition series, then they show the similar physical and chemical properties. This is because their size is same. And why their size is same? Because of lanthanide contraction, right? So that is because they have similar atomic radius, option number C here. Next, why is HCl not used to make the medium acidic in the oxidation reactions of KMnO4 in acidic medium? So we cannot use HCl because KMnO4 oxidizes Cl minus to Cl2. Okay, KMnO4 minus oxidizes, or KMnO4 oxidizes Cl minus to Cl2. So we have both HCl and KMnO4 acting as an oxidizing agent. KMnO4 oxidizes HCl to Cl2, which is also an oxidizing agent. Yes, that is the answer here. That is option number B. Now we'll move to coordination compounds. Here, a purple compound M has a formula CONH3 6Cl3. On adding excess of AgNO3 to 1 mole of M produces 2 moles of AgCl. That means 2 moles of chlorine will be outside. If the secondary valency of cobalt is 6, then the correct formula of the complex will be. Okay. So we have this one, CONH3 whole 6 Cl. Okay. Okay, 1 second. See, you are getting 2 moles of AgCl, right? 2 chlorine should be outside. Okay, but 1 chlorine is extra. We cannot put that chlorine inside. So that chlorine has to be inside. And if that chlorine is inside, then 1 NH3 has to be outside. See, we have to write like this then. NH3 whole 5 Cl, Cl2 and then NH3. So we have only 2 chlorines. We will get 2 AgCl. The coordination number of 6 is also satisfied. So can we see any formula like this? Yes, that is your option number C. Okay. Next, question number 42. Which of the following is not a double salt? So if you see, more salt, potassium, carnallite are all double salt, but potassium ferrocyanide is a coordination complex. So that is your option number D. Next, the correct order of the stoichiometries of AgCl formed when AgNO3 in excess is treated with the complexes, this one. Okay. So here you will get 3 Cl, so 3 AgCl will form. Here we have cobalt, coordination number is 6, means cobalt should have 6 bonds, right? So if I see the first one, I will write like this, CONH3 whole 6 Cl3. Then next one here we have is CONH3 whole 5 Cl, Cl2, and then here we have CONH3 NH3 whole 4 Cl2 4 5 6 and then Cl. Okay, so here I will get 3 moles, here I will get 2 moles, and here I will get 1 mole. So 3 2 1, that is option number B. Okay. Next, question number 44, which among the following has the highest molar conductivity? So the highest molar conductivity will depend on the number of ions that is produced. So here I have 4K and this one complex, so the number of ions produced here is 5. Here the number of ions produced is 4. Here the number of ions produced is 2, and here the number of ions produced is 1. So the highest molar conductivity will be with option number A. Next, we have the primary and the secondary valencies of the following. So if I want to calculate, here the coordination number is 6 because C2O4 is a didentate ligand. Okay, so each C2O4 has 2 bonds, so means each C2O4 forms 2 bonds with iron. So 3 C2O4 will form 6 bonds with iron. So secondary valency will be 6, and this one if you calculate, the primary valency will be plus 3. Okay. Next, we have question number 46. Coordination number of the central atom or ion is determined by. Yes, coordination number is determined only by the number of pi bonds, both by the number of sigma and pi bonds, only by the number of sigma bonds, by the total number of electrons present in the ligand. It is determined by the number of sigma bonds, only by the number of sigma bonds. So correct answer is option number C here. Next, we have the correct IUPAC name of this particular compound is, so you can see this is potassium. Okay, then we have trioxalato, potassium trioxalato, chromium. Okay, chromium is a negative complex, so name has to end with chromate. So first option we can eliminate. Potassium trioxalato, here it is tris, that is not there. Here tri is not mentioned, this is also not there, so directly I can write option number B. Next, PTNH3 whole 4 Cl2 Br2 complex can show hydrated. No, it will not show hydrated because there is no water molecule. Eliminate this one. Ionization as well as geometrical. Linkage, will it be there? Ambidentate ligand is not there, so no linkage. Ionization as well as optical isomerism. Okay, can we have okay, just a minute. First of all, yes, ionization isomerism is definitely there because here there can be chlorine and bromine can interchange. Now, if I see regarding geometrical and optical isomers, yes, geometrical isomers is obviously there because it is having cis and trans form, right? So that is why option number B is the correct answer. Next, we have here possible isomerism in the complex, this one and this one respectively are. So if you see here, we can have NO2, so there can be linkage isomerism. So one will be linkage, I can eliminate these two, right? In this we will definitely have linkage isomerism. And for the next one, that is here, we have CONH3 whole 5 NO2 Cl2. So yes, here we can have optical isomerism. Do we? Let's check here. So I have CONH3 5 and NO2 group. There are 5 NH3 group, NH3 and 1 NO2 group, right? So if I draw the mirror image, it will not be superimposing, right? So yes, we can have optical isomerism here, linkage and optical. Okay, why not geometrical? Because you cannot have cis and trans here because there is only one different group, it cannot have cis and trans form. Okay, next, in the reaction here, 2 isomers of the product are obtained. So the initial complex is, okay, so this is again a tricky question. See, when the reactant is cis, okay, in the product you will get trans plus cis. Okay, so if you are getting 2 products, that is trans and cis, then the reactant must be a cis isomer. So correct answer is option number A. Okay, now moving to the next chapter, haloalkanes and haloarenes. Okay, so here the first question, chlorine containing antibiotic used in the typhoid fever is nothing but your chloramphenicol. Okay, next, the halogen containing compound used as an anesthetic during surgery is your halothane. So these are the fact based questions, you should be remembering them. Okay, next we have 1,1-dichloroethane is also called as, so it is a geminal dihalide. So you can see 1,1-dichloroethane, right? 1,1-dichloroethane, it is a geminal dihalide, and the common name for this one is your ethylidene chloride, option number A. Okay. Next, we have the total number of structural isomers possible for the compound having the molecular formula C5H11Br. So we have this one C5, okay, the total number of structural isomers possible. Okay, so we have this first one where I can put Br here. Next, in this chain only, okay, I can put Br here, and I can put Br here, right? With 5 carbon chain I am getting 3 isomers, right? Then I can try this 4 carbon chain. 4 carbon chain suppose I have, then I can put Br here, that will give me 1 isomer. I can put Br here, I can put Br here, and I can put Br here, right? Yes, here or here is the same thing. 2, 3, 4. So 3 plus 4, I got already 7. So 8 is the only option left, I think, right? So then if I have a 3 carbon chain, right, here anywhere you put it is the same thing. So that is why the correct answer will be option number 8 here. Option number C, that is 8. Next, which among the following has the chiral carbon? Chiral carbon means a carbon which has 4 different groups. So if you see 2-chloro, 2-methyl propane, no, 2-chlorobutane if you see. Okay, so this side methyl group, this side ethyl group, this side chlorine group, and this side hydrogen group. So that is option number C here. Next, the alkyl compound having the largest CX bond length. Okay, largest CX bond length means this bond should be very weak. So iodine being a very big mass, okay, the bond, the overlapping is very weak, and here the bond is very weak. Bond is very weak, so bond length will definitely be more. So that is option number C here. Next, the alkyl compound having the largest CX bond enthalpy. So where the bond strength, here the bond strength will be highest. If bond strength, bond length will be smallest, bond strength will be highest, so bond enthalpy will be highest. So that is why option number D here. The alkyl compound having least dipole moment. Dipole moment again depends on what? The charge, the electronegativity. So here the electronegativity is the least one, charge is less, so dipole moment is least here. Okay, next, the best reagent used to produce pure alkyl halides from alcohols is your SOCl2. Why? Because the byproducts produced here are completely gaseous, it can evaporate, we can get pure haloalkanes. Next, aryl halides cannot be prepared from phenol because phenol is more reactive? No. Aryl halides is more reactive? No. Carbon-oxygen bond in phenols has a partial double bond character. Yes, that is why the bond we cannot break it, and that is why we will get this one. The bond we cannot break it, and it cannot easily give you the new product. Next chapter, alcohols, phenols and ethers. The COH bond angle in alcohols is slightly greater, slightly less. So if you see, it is like this. Okay, oxygen has 2 lone pairs. There's a repulsion between this lone pair. That is why it pushes these 2 together, and this bond angle decreases. So slightly less than 109.28 degree. Next, we have identify the simple ether from the following. Simple ether means both sides of the O should be same. Here you can see it is different. This one is same. This is different. This is different. So option number B here. Next, which of the following types of alcohol contains a bond between sp2 hybridized carbon and OH? So you can see here that is vinylic alcohol, sp2, this is your vinylic alcohol, sp2 carbon containing the OH group. Okay, next we have which of the following terms does not describe this one. Okay, so this is not vinylic, this is obviously primary, this is allylic, and this is also monohydric, but not vinylic, because we discussed what is vinylic alcohol. This is vinylic alcohol where the OH is directly attached to an sp2 hybridized carbon. Next, moving to 66, which of the following compounds OH group is bonded to the aryl carbon? Yes. So in phenol, what happens? The OH group is directly bonded to the aryl carbon. So that is why option number B here. Next, ROR, where R represents an alkyl or group, is the general formula of which compound? This is very simple. This is your ether, right? Option number D here. Next, IUPAC name of metacresol. So if you see, metacresol is like this. You have OH and you have CH3. So you can write down 3-methyl phenol. That is option number A here. Okay. Next, the correct IUPAC name of the given compound. Okay. So I can just see, I can number it like this: 1, 2, 3, 4. So 2-methyl, right? 1, 2, 3, 4. Yes. So 2-methyl butane 2-OL. Can I get that? 2-methyl butane 2-OL, option number C here. Next, the CO bond length in phenol is less than in methanol due to, yes, CO bond length just now we discussed. In phenol, what happens? If you have this one, okay, in phenol what happens? There is a partial double bond formed, right? Now due to this partial double bond character, the bond length will decrease. So that is because of partial double bond and sp2 hybridized carbon, both are the reason. So that is option number A and B. Next, Dasson reaction with B2H6 gives trialkyl boranes. So that is alkenes. On reaction with B2H6 gives trialkyl boranes. Next, aldehydes, ketones and carboxylic acid. So first one, which of the following compounds do not contain a carbonyl group? Aldehydes contains ketones, contain carboxylic acid also contain. Carbonyl group means this group. Okay, so it is option number A. Next, question number 72, how many carbon atoms does a formaldehyde have? So a very similar, very easy question. Formaldehyde have only one carbon, right? So that is option number B here. Next, what is the common name of the compound which has a CHO group attached to an sp2 hybridized carbon of a benzene ring? So you have a benzene ring and to the sp2 hybridized carbon CHO group is attached. This is nothing but benzaldehyde, that is option number B. Which of the following is the incorrect name of the following compound? So 1, 2, 3. 3-methyl butanol. Yes, 3-methyl butanol, option number A here. Next, 75, the prefix valor is generally used for naming aldehydes with how many carbons atom present in the structure? This is very important question. Valor aldehyde is used for number of carbons when it is 5. Let us see the next question here. The correct IUPAC name here is, this is cyclohexane. So it is not cyclohexanol. Whenever a cyclic ring is having CHO group, so it is cyclohexane carbaldehyde. Okay. Next, which of the following method cannot produce aldehydes? Oxidation of primary alcohols. Yes, that will produce. Dehydrogenation of secondary alcohols. No, secondary alcohols will not produce alcohols. It will produce ketones. So that is why option number B here. Okay. Next, we have which of the following reactions can produce ketones? Yes. Oxidation of primary alcohols? No, that will give you alcohols. Dehydrogenation of primary alcohols? No. Dehydrogenation of tertiary alcohols? No. Oxidation of secondary alcohols will give you ketones. Next, what is the catalyst used in the hydrogenation of acetyl chloride to produce ethanol? Okay, so this is your Rosenbaum reaction, right? H2 palladium over barium sulfate, that is option number C. Let us see the next question here. Which of the following carbonyl compounds cannot be prepared from Rosenbaum reaction? So, can be prepared. So, Rosenbaum reaction is for the preparation of aldehyde. So, ketones we can eliminate. Methanol also we cannot prepare because the acid chloride that is required, this one is highly unstable. Okay, so that is why benzaldehyde can be prepared by using this method. So, option number D. Now, moving to amines chapter, consider 3 gaseous alkyl amines, 1 degree, 2 degree and 3 degree. What will be the order of their basicity? So gaseous amines, we know it is 3 degree, 2 degree and 1 degree. So CBA. Why? Because we have 3 R groups, right? Because we have 3 R groups, what will happen? It will donate more electrons, the electron density will increase, so the basicity will increase. Next, which of the following groups when present at para position increases the basic strength of aniline? So to increase the basic strength, see, aniline is there here, okay, it has to donate electron. So at this group, this para position, there should be one electron donating group which can increase the electron density, and here the electron can be donated. This is one withdrawing group, this is withdrawing group, this is having minus I effect. NH2 is a proper electron donating group, so this can increase the basicity. Next, which during the acylation of an aliphatic primary amine, which of the following is replaced by an acyl group? So if you have RNH2, okay, and we have here acylation, that is CH3C double bond OCl. So what will happen here? H is replaced with COCH3, okay, and HCl will form, and this H is replaced with COCH3. So what I will get? RNHCO and CH3, okay. So NH2 group, one H atom of the NH2 group, so that is the correct one, that is option number B. Both H atoms, no, only one hydrogen atom is replaced. Next, what is the most suitable temperature for the diazotization reaction to take place? So it is between 0 degree to 8 degrees Celsius, or you can say at 273 Kelvin. Next, aromatic diazonium salts are stable at, again the same thing, at a cold temperature, okay. Next, we have in the reaction of diazonium salts involving the displacement of diazonium group, the nitrogen escapes as, it escapes as N2 gas, so that is why option number. So let us see the next question here. The coupling reaction is a type of electrophilic substitution reaction, so option number B. Next, the gas liberated when ethyl amine reacts with HNO2, so we will get nitrogen gas, N2 gas and alcohol. The amine which cannot be prepared by Gabriel phthalimide, so it is used for the preparation of aliphatic primary amines, so we cannot prepare an aromatic amine aniline, so option number C. Which amine will not be precipitated when heated with Hinsberg reagent? So primary and secondary will react, tertiary will not react, so option number C. Next, moving to biomolecules chapter, the reaction of glucose with acetic anhydride confirms the presence of 5 OH groups because there is a pentaacetate formed here. The alpha D glucose and beta D glucose isomers of glucose are known as anomers because they differ in the position of only one carbon, number 1, right? Next, identify the compound from the Howard projection. So you can see here it is alpha. So alpha, alpha, eliminate these two, and this is a hexagonal structure, so it is pyrano, so option number A here. Next, the two monosaccharides are joined by a glycosidic linkage. Two amino acids are linked by a peptide linkage. Two nucleotides are linked by a, what we call it, phosphodiester linkage, okay. Next, question number 96, sucrose is made up of alpha D glucose and beta D fructose. Which of the following statements is incorrect regarding a starch? It is a reducing carbohydrate. No, it is a non-reducing carbohydrate. Doesn't have any free aldehyde group, so option number A. Cellulose is a beta straight chain, okay. Glucagon is a structure having similar to your amylopectin, so it is branch chain, but yes, cellulose is a beta glucose straight chain. Proteins are the polymers of alpha amino acid. And the last one, which of the following amino acids is optically inactive? That is glycine, because we have the structure of glycine like this, NH2 and COOH, right? Here the two groups are not different, so it is optically inactive, okay. So yes students, that's all top 100 questions, but I will suggest you that MCQs you cannot just limit to these 100 questions because these are definitely the most important, but MCQ can be asked from anywhere. There is no most important MCQs, that concept is not there, to be frank. So if you have time, do this 100 MCQs. After that you can please refer to my Chakraview series where each chapter I have given you 70 questions, okay. So just imagine per question per chapter, if you are doing 70, 60, 70 questions, questions, you will become very strong in your MCQs. So if you have time, at least of the high weightage topics, you can go and do the MCQs. Okay, so that's all students. I hope you are preparing really well, and these series of mine are really helping you in your preparation. So if you want any other videos, any other help, please comment down. I will definitely address to it. So thank you so much and all the best for your preparation.